In this video, we introduce the Texas grid model. This network is a 2,000-bus synthetic network model of the Texan transmission system, which was created using network data made available by the Texas A&M University. The model doesn't represent the actual Texas grid in terms of location, but does use generation and load profiles based on publicly available data. This project can be used to carry out calculations that are of interest to transmission system owners and operators. The network consists of 8 interconnected grids, as can be seen in this geographic diagram. The diagram has been constructed using geographic coordinates for the sites and substations. Another feature of this diagram, and also of the schematic diagrams that you see to the right, is the use of filter layers to represent the different voltage levels. For example, we can show just the 500 kV and 230 kV elements. If we want, we can also color the diagram according to layers and use this to see the different voltages that are in the network. Within the network, the demand is represented by load objects and generation by synchronous machines. Parameter characteristics to the resolution of 1 hour are available for the active power of both loads and generators in order to model the variation of those over time. Let's have a look at a couple of examples. This generator represents a wind farm. Here we can see the associated characteristic. Likewise, here we see the characteristic that can be used to model demand variation over the year. In this base case, the characteristics are not used, but they are activated for other study cases where time sweep calculations are executed. Let's now activate this next study case and run an AC load flow calculation. The diagram is now colored to show high and low voltages and loading, and we can see that there are no voltage or loading issues. This grid interchanges diagram shows the power exchange between the grids. For each grid, the imported and exported active and reactive power are shown, together with the net interchanges. The relative thickness of the lines between the grids indicate the level of power flow, and by inspection, the north-central grid has the largest net active power import. We can see this more clearly on this plot that shows the net import and export of each grid. The lower plot shows the maximum and minimum voltages in each grid. The results confirm that, in this case, the voltage levels all lie within a range of plus or minus 0.05 per unit. The remaining study cases in this project illustrate a number of calculation functions, many of which are demonstrated by other videos in this playlist.